Hi, welcome back to Foresight on the Road here at 6K. I'm Brad Van Valkenburg, sitting next to Frank from 6K Additive and Bruce from 6K Inc. So far, we've talked a lot about their sustainability journey and the work that they've done and what's come out of that. But what I thought was really interesting about them, which is why I'm leading this one and I subbed Danny out, is their process of how they make their materials. So I just kind of want to start with specifically 3D printable powders, which is what we did the study on. So comparatively of what were the traditional methods to produce them, and then how have you taken that and reinvented it basically from the ground up to make your product?
Yeah, so traditional methods of making spherical powder are atomization methods. So either plasma atomization or gas atomization, where in part you're ultimately melting either via plasma or some vacuum induction process. You're using gases to essentially atomize a molten pool. The benefits, so you get a nice particle, round, spherical, semi-spherical particle. The challenge is you get a very wide particle size distribution. And so our methodology is leveraging what's behind us here, the Unimelt, the microwave-based plasma, as a spheridizer. So essentially what we're doing is bringing in secondary materials, all aerospace grade scraps, and we size them, essentially get them into an engineered feedstock, which is the right chemistry and it's the right volume of particulate. It's just the wrong shape. And so we're doing that in very highly efficient mechanical operations. And then we only put the real work in, the real energy into the product when we have it at the right chemistry and the right volume of particle. Inject them into the microwave-based plasma. The key with microwave-based plasma is it's very uniform in terms of temperature. So the 6,000 degrees Kelvin, hence the 6K. You basically have the ability to digitally tune resonance time, so time at temperature. So as you're injecting particulate into the Unimelt, it sees that time at temperature for a very precise amount of time and starts to heat up, turn to molten. The surface tension of the molten metal causes it to form a sphere, and then it cools very quickly. And so essentially you're effectively getting nearly 100% yield, 95-ish% yield, versus some of the legacy technologies in 3D printing. It's a narrow cut that they're putting in the printer, and so some of those legacy technologies can be as low as 30%.
So instead of having a chaotic process of taking hot molten metal and shooting it with pressurized gas and exploding into a bunch of different particle sizes where only 15% is usable.
Yeah.
You're taking that out, making sure that only the good things go in, and there's a much simpler, not simple, but much less chaotic, peaceful operation. Just feeding them in, let them fall through and shape into spheres.
Think of it very laminar. It's a very laminar
versus
process.
a very turbulent on the other side.
Versus very turbulent.
And what's cool about it, the Unimelt itself, I referenced this before, other divisions, it's a very flexible system. Frank's putting in solids. On the energy side, we actually spray in liquids. So on that side, we talk about infinite material possibilities. So we can do infinite materials in theory on the additive side, but as well on battery. So the technology itself, and it's all made possible because of the microwave plasma and how we have the ability to control that plasma to do so much more with it than somebody else. There are others in the industry that actually utilize a plasma, but they don't use the microwave. So one of the atomizers is a plasma atomization. They can do it, they do a decent job, but they just don't have the control and flexibility.
Right. So you developed a brand new process or a technology here that can be used across multiple fields for multiple materials, but it's a new process to actually use this microwave plasma effectively.
Exactly.
Yep. All right, that's all for us on this episode of Foresight on the Road with 6K. Thank you all.